three-step equations, notes number 3. Some of this you guys should be able to do just fine. This is a little bit of a review again. A number sentence is a statement of equality between two numerical expressions. A number sentence is said to be true if both numerical expressions are equivalent. That is, both evaluate to the same number. It is said to be false otherwise. True and false are called truth values. Determine whether the following number sentence are true, or this is supposed to say or, okay, or false. Justify your answers. All right, so justification is basically showing your work. So I'm going to take a piece of paper and I'm going to write A. I'm going to write parentheses 71 times 603 times 5876 is equal to 603 times 5876 times 71. Remember that you need to use Pemdas, right? Your calculator will automatically use Pemdas for you, and we're just going to go to doing that, but we're going to show our steps of Pemdas. So I'm going to do, in my parentheses, I'm going to do 71 times 603, and I get, ooh, this is on scientific. Be careful, some of these students on Friday did not reset their calculators. So you will have to, this one's obviously not reset. So I've got 71 times 603, and I get 42,813 times 5876 times 5876. And if you notice, I never put the 4218 back in. I just used the answer from my previous and multiplied it. And I got 251569188. I'm sure you wanted to do that math, right? All right, so over here, I got to do what's in my parentheses, 603 times 5876 times 71, and I get 4177. Ooh. And if you notice, what property was used for this problem? Times 603. Numbers are the same, right? They just move the parentheses. Associative. So it would have come out, you knew it would have come out if you looked at it and thought about it. It's all multiplication, and the numbers are the same. They just put they wanted you to do this first instead of that first, and when you're multiplying across, it's always going to work. So what we would do here is we would write true, okay? And this is our justification. So B is 7 plus 9 squared is equal to 7 squared plus 9 squared. Do you think this is going to work? Just looking at it.
Yes.
I got one no and kind of a yes. Not sure. You say no? Think about it. What do I get when I get 7 plus 9? So are you telling me that 16 squared is going to be the same thing as doing 7 squared plus 9 squared? I don't know. 16 squared is 256. 7 squared is 49. 9 squared is what? Come on, 9 times 9. 81. When you add 49 and 81, what are you going to get? 130? That's correct. Are they equal? No, because 16 times 16 is much greater than the other side. Okay, so you just write false. Easy enough, right? Alrighty, next, see. So it's showing you, we're working with our properties, showing you how they work, and you're trying to determine if the statements are true. What about this one? Look at that. Anybody tell me right off the bat whether they think it's going to be equal? Not really? What is this? What do I have to do with that 4? I have to distribute, correct? So 4 times x is how much? 4x. Hey, that matches. But 4 times negative 5 is what? Negative 20. So, do I have to go any further? No, because look, if they don't match, we're not going to try and solve for x. We're just trying to see if the sides are equivalent. So, they do not equal. Therefore, C is false. Okay? Keys to success. Define your variable. Write an expression for each side of the equation. Solve your equation. Distribute to get rid of the parentheses. Combine like terms if they're on the same side of the equal sign. Get variables on one side of the equal sign and your constants or your numbers on the other side. Use inverse operations. Undo addition, subtraction first. Inverse operations, undo your multiplication and division last. So there's your steps. Check your solution. Make sure you've answered the questions. So, example 1. I've got 4x plus 3x is equal to 560. You guys should be very good at these. What do I have? 7x is equal to 560. Divide both sides by 7. And I get x is equal to, what's 56 divided by 7? 8, and add your 0. Okay? That's all there is to it. Uh-oh, I didn't even get that on this. Oh, I hate these things. Sorry. I might not have had this showing very well all the time. So I'm going to write on my paper my answer. X is equal to 80. And, okay? Da-da-da-da. Okay? So, number 2, let's say it says you try it. So, let's try you try it. Okay. If I was to check this over here, what would I do? I guess I should have done a check.
You would plug in
80 for x, correct. And I would get 4 times 80 plus 3 times 80 is equal to 560. 4 times 8 is what? 32, and add your 0. 3 times 8 is what? So 24, and add your 0. Do you see how easy it is to multiply with multiples of 10? 560, and I get 320 plus 240, which gives me 560 is equal to 560. Therefore, my answer is correct. Isn't that nice? Okay. All right. Let's look at A. 2r minus 6r plus 8 is equal to 40. What was the first step it said to do? Get rid of parentheses. I don't have any. Combine like terms if they are on the same side of the equal sign. So what am I going to combine here? 2r and negative 6r, right? And what am I going to end up with? I heard it. Negative 4r plus 8 is equal to 40. Then it says get variables on one side of the equal sign and constants or numbers on the other side. So subtract 8. Using inverse operations, we're going to do the addition and subtraction first. Then we will do the multiplication. So 40 minus 8 is 32. Divide by negative 4. And I get r is equal to 8. Correct? Oh, thank you. I was just waiting for somebody to catch me. When you have a negative sign, you need to make sure it's dark enough I can read it. Some of you guys use those number 5 pencils or whatever, and they write really light because you write really light, and it's really hard to see, and I gotta go like this, and I'm old. So make sure I can see those negative signs, all right? All right, let's go turn the page. Let's do example 2. Example 2. I'm not going to do the checks on all of them because we'd be here all day. Plus 3 is equal to 46. So we've been doing these. We did these before. What am I going to do? Distribute. 2 times 4 is what? 8x, 2 times positive 3 is plus 6 is equal to 46. Subtract 6. Do you guys like puzzles? Algebra is puzzles. It's just puzzles. It's like getting all the pieces in the right place. 8x is equal to 40 and divide by 8. These should be pretty simple and for you. 40 divided by 8 is 5. I mean, this is just kind of a review of what we already did and what we reviewed as far as equations when we first came to school. Some of them are a little more complicated, but not really. A, if you just do them in the steps that you're supposed to do them, you will be just fine. 5x plus 3 parentheses x plus 4 equals 28. So first step was get rid of the parentheses, right? Well, then also Pemdas would tell you to multiply. You really can't multiply this, can you? And you can't really add anything in here, though, can you? So we're going to distribute the multiplication first. So 5x plus 3x, 3 times 4 is plus 12, is equal to 28. Okay? Then combine like terms on the same side. So I've got a 5x and a 3x over here. So I've got 8x plus 12 is equal to 28. Next step, get rid of that plus by doing the inverse operation, which is subtract. I bring down my 8x is equal to 16. And divide by 8. And I end up with x is equal to 2. Now, you knew it couldn't be this easy the whole way, right? It just wouldn't be algebra if it was this easy the whole way. So here we go. Example 3. I'm going to put my paper underneath here. The three angles of a triangle are represented by the expressions 3x minus 14, x, and x plus 4. Recall that the sum of the angles of a triangle is 180. Write an equation and solve for each angle. Okay, so basically, you have a lovely little triangle. Okay, and I'm going to do this. This is example 3. All right, and I am going to put my information over here so I have it available. I've got 3 angles. So angle number 1, number 2, and number 3. Okay? Yes. Oh, I'm so sorry. It's trying to work with both of these little machines here. I guess I need to move this over. I'm always constantly looking here, worrying about whether it's recording instead of looking there. All right. So, what was angle number 1? It told you in the little sentence what was angle number 1 equal to.
3x minus 14.
So 3x minus 14, and angle number 2 is just x, and angle number 3, x plus 4. And it even told you, which it always will not, you're going to need to have some things in that handy-dandy toolbox of your head. The total of 3 angles in a triangle are 180 degrees. You guys should have learned that when? Last year, maybe? I'll try and warn you about things, but you're going to need to know how to find perimeter of a rectangle, area of a rectangle, because you're going to be now putting equations in for them instead of just numbers, okay? So we'll get there, and I'll remind you of the formulas, and because they're no longer on your formula chart. You need to have those in your bank, all right? So it wants to know how much is each angle. The question is the degree, right, of each angle. So degree of each angle was the question. You know this sign means degree? I should have probably written it for you, but it's a little 0 kind of like an exponent, if you see something like that. So, let's see here. Each angle they want to know. So, I'm going to set up an equation. I've got, and I'm going to do this so I don't get confused, 3x minus 14 plus x plus 4 all equal 180 degrees. Ooh, I don't like where I did that, but that's okay. I'll show you why in a minute. Okay. I'm going to do, so combine like terms. Don't try and do both at the same time, okay? Do your x's, then do your constants if they're on the same side. So I'm going to put a 1 in front of both of these so I remember I have a 1 to add. So I'm going to do 3 plus 4 plus 5. So I have 5x minus 14 plus 4. Some of you will try and skip and do that all in one step, and you will make mistakes. So please, at least for the next little bit, just do it separately. All right, so I still have 5x minus 14 and a plus 4 is going to give me what? Negative 10 is equal to 180. Now it says to get rid of and put constants and variables on the same side, so I'm going to add 10 to both sides. I get 5x is equal to 190. All right, divide by 5, and I get x is equal to 38. Now, does that answer my question? So if I gave that answer to the teacher, would I get that correct? No, I wouldn't. Sorry, but this is driving me insane. These things have got to grow out at some point. All right, so what do I need to do to find the answer? I have to plug it back in. So the reason I said this was a bad place to be is because I should have worked each one right out from it, and then I wouldn't have to rewrite them. Does that make any sense? So I've got number 1 is 3x minus 14, which if I substitute that in, I got 3 times 38 minus 14. This is where I would use my calculator, and I would do 3 times 38 minus 14 in my calculator. Most of you are doing it. And I would hit an equal. Okay, so angle number 1 is 100, isn't it? Angle number 2 is just x, right? Okay, so we know that angle number 2 is 38, isn't it? Don't need to do any calculation there. Number 3 is x plus 4. So if I substitute 38 plus 4, I get 42. Now, I am going to do a check, and the easy way to do a check is this. I know that all 3 angles, 100 plus 38 plus 42, have to equal 180, don't they? So 100 plus 38 plus 42 do equal 180. So 180 equal 180. So this is what I would be making sure and writing on my paper. Number 1 is equal to this. Number 2 is equal to this. Number 3 is equal to that. So number 1 is equal to 100. Number 2 is equal to 38. Number 3 is equal to 42. And there we go. Okay? Not bad, right? Okay, this is always a fun one. And I'm going to need another piece of paper. How sad. All right. Write and solve an equation. Only an algebraic solution will be accepted. In other words, you can't just figure it out in your head. You got to tell me how you got there. Okay? All right. So, this is try it A. Sam's father is 3 times Sam's age. The sum of their ages is 56. How old is Sam's father? So I know this. The question is age of father. Okay. I've got Sam. I've got, what else did they tell me? They told me the sum, right? I've got a father in there that I need to know the age. And they told me the sum of their ages, didn't they? So I am going to, we know what Sam's age is, right? It's 3 times the father. So if they tell you that, they're basing everything off of whose age? The father's, okay? So we can let X equal the father's age. Because they've told you, if I make X the father's age, they've told you that Sam's age is 3 times the father's age. Okay? And so then they told me the sum or the total is how much? 56. So now it's pretty easy to write an equation and find out. The answer they really want is how old is Sam's father. So I'm going to come over here and I'm going to say 3x plus x, and I'm going to make that a 1x so I don't forget, is equal to 56. 4x is equal to 56. Divide both by 4. And I would use a calculator if I didn't know this because it's just simpler. For now, you can just start doing your computations with a calculator. X is equal to what? 14. So I know the father's age is X is equal to 14, isn't it? That's the only answer that they've asked you to get. If they asked you to get Sam's age, then it would be 3 times 14, which would be 42. And then my check could be 42 plus 14 is equal to 56. Guess what? I got 56 is equal to 56. I'm good to go. So I know that my answer is correct. So I write father is 14. 42. Oh, they want Sam's age. I'm sorry. Sam's father, how old is Sam's? No, how old is Sam's father?
Sam's father is 3 times Sam's age. Yes.
So I set it up wrong. Oh, thank you so much. So the whole thing was set up backwards. This is the father, and this is Sam. Right? I am so sorry. Sam's father is 3 times Sam's age. And when I went to go write this here, it didn't make any sense to me because how can Sam's father be younger than Sam?
Yeah, I was wondering
You
that
know?
too.
You know, that would be kind of a trick. I don't know. I haven't never heard of that before. I'm sure, you know, with how they save all that kind of stuff and do stuff, maybe it's possible. I don't know. No, because they still have to, no, it wouldn't be possible. Never mind. Not going to get into there. So the father is 42, and I'm done. Yeehaw. Yeehaw, yeehaw, yeehaw.
Well, maybe it's a stepdad.
Ooh.
That'd be gross.
Ooh.